I welcome you to Lecture 9, which discusses two important effects, the albedo effect and the greenhouse effect. This lecture has three parts. Part A focuses on the albedo effect. We talk about different optical properties of different surfaces. I show you the albedo distribution on Earth. Okay? We talk about the average albedo. And we answer the question of how much of insolation reaches the Earth's surface on average. Part B focuses on the greenhouse effect. I give you a simple explanation. Then we talk about radiation spectra and absorption bands of gases, including greenhouse gases, to understand the details. In Part C, I introduce you to simple radiation models. We look at radiation budgets and balances, and we calculate the emission temperature of Earth if we ignore greenhouse gases, or if we assume that greenhouse gases absorb all radiation that the Earth emits. Okay, let's get started. Part A, the albedo effect. Albedo is simply the amount of solar radiation that a surface reflects. And the amount reflected depends on the optical property of a surface. Okay? Black surfaces, okay, have a low albedo. White surfaces have a high albedo. Okay, in this context, it's also important to look at the absorption. If you look at surfaces, the black surface absorbs a high proportion of the incoming radiation, while the white surface only absorbs a little of the incoming solar radiation. So let's have the storyline here of this lecture is, well, we worked out the average insolation at the top of the atmosphere. So this is the average amount of solar radiation that reaches the top of the atmosphere. And we worked out that this is 342 watts per square meter. However, we have now this albedo effect. Different parts of the Earth's surface. We have different optical properties. We have water, we have ice, we have wet soil, we have grassland and all that stuff. How much of the insolation reaches the surface? Okay? So a fraction of solar radiation becomes reflected back to space, known as albedo effect. And it's clear that the albedo effect has a cooling effect on climate, because it just reflects some part of the solar radiation back. And above my head is the albedo of common surfaces. You can see, it's expressed in a range of 0 to 80%. Okay, and fresh snow, according to this distribution, has the highest albedo compared to other surfaces like water surface and so on. Let's look a little bit more into detail. Okay? So the albedo value is a function of the optical properties of a surface. It ranges between 0 and 1. Okay? 1 means 100% reflection and 0 means no reflection. Okay? And as I said before, that has consequences. If there's no reflection, then either the other amount has to be transmitted or absorbed. In terms of the surface, it means absorption. Okay. And above my head is a little sketch for urban environmental albedos, okay, and linked to the urban heat island. You can see that asphalt has very, very low values. It's a dark surface, and it means that it also stores lots of thermal energy and actually radiates itself. It creates a warm environment. You have a look at I have to get apparently the mouse working here, but here, look at that asphalt and compare with colored paint the values. Okay, you can see how much albedo can change over small spaces. Okay, so white surfaces generally have a high albedo and black surfaces have a low albedo. And here's another table which shows you the albedo as the function for different soil types, dark and wet versus light and dry. You see the range here of albedo. Long versus short grasses, agricultural crops. We look at forest, water surfaces, snow surfaces. Fresh snow has the highest value. It reflects almost all of the incoming solar radiation. And then we look at ice has a relatively high albedo, and clouds can have extremely high albedo of 0.9 as well. Okay, so that's important to learn the albedo, and I showed you the link to the microclimate. So albedo effects are important on on small spatial scales. They're extremely important. So if put a roof on your house, it matters whether you choose a dark or a white surface, or a reflective or a non-reflective surface. Okay, all right. So let's look at the global distribution of albedo. And this one is a movie. A movie goes from 1 month to the next, shows you the distribution of albedo. And you can see seasonal variation of albedo, and that's associated with ice distributions and with the humidity distributions, or whether you have wet surfaces or whether you have dry surfaces. Okay, and you can see the range here in colors is between black is 0 and red is 1. Okay. The fact that the ocean is all dark here doesn't mean that it's 0. You can see that all the range between 0 and almost 0.1 is actually very dark. Okay? Anyway, you know that the oceans cover around 3/4 of the surface. So you would actually expect, if you work out an average albedo, that it actually turns out to be relatively low. Okay, so let's see what if we do that. Okay, we know from that we can calculate the average albedo. Okay, we can work out it's about 0.3. Okay, so on average, 30% of the incoming solar radiation is reflected. 30%. So now we answer the question. So if we have 342 watts per square meter coming in at the top of the atmosphere, we can work out that 70% of this reaches the surface. 70% is 100% minus 30%, which is the albedo. So 240 watts per square meter is the magic number. Okay? In some textbook you see 242 watts per square meter. These are just small variations. So 240 watts per square meter is the golden number. This is what we use in future consideration. Okay, so this answers our question. So how much is that 440 watts per square meter? So you can just imagine 1 square meter, and you put some light bulbs on there. So something like, if you have 60 watts light bulbs, you just take 4 of them. So each square meter, the solar radiation could, power 4 60 watts light bulbs. Okay, per square meter on average. So this is to get an idea of how much it is worth, that amount of energy. Okay, in terms of microwave, in order to run a microwave, you need the average energy distributed over 2 by 2 square meters. So you get actually 4 blocks of square meters. You get 1,000 watts distributed over these four blocks. All right, so I hope that helps you a little bit to understand how much of the solar radiation ends up at the surface, noting that the polar regions reflect most of the solar radiation, because there you have the snow and ice effects, the albedo effects. Okay, so this concludes the first part of this lecture.